and it looks like this. We have to have, these are decimal points, by the way. We have to have a system to decide which ones of these numbers are significant, meaning where did they make a measurement? How good are these numbers? Okay? Now your book goes through some rules on how to decide with zeros. I saw like 2 years ago, because this is what I do in my spare time, is trying to, because students often struggle with significant figures. They hate them. Never have a student ever had to say to me, Dr. Powell, I love significant figure problems, can we do more? They hate them. Because number one is they don't know how to decide what's significant and what's not. Here's the easy thing to do. I'm going to write one more number up here. Okay? Here's a rule. And I found this on the internet, and if I can find it again, I'll post it at Blackboard. I'll post the link to it. If there is a decimal in the number, we're going to start from the left, and we're going to mark out all the zeros until we come to a non-zero number, and then everything that's left is significant. So we're going to start here, because there's a decimal. We stop there. Everything that's left is significant. So how many significant figures are in that first number?
4.
There are 4 sig figs here, right? All right. What about this one? There's a decimal, right? So we're going to start from this side. We mark out to there. Everything that's left is significant. How many?
3.
3. All right. Now this number, does it have a decimal?
No.
So we got to start from the right-hand side. How many sig figs?
2.
Only 2. Yes, ma'am.
So when there is decimals, you start from the left, and with no decimals, start from the right?
Yes, and cross out zeros until you get to a non-zero. Yep. One more example. Or how many sig figs here?
4.
There are 4 here, right? Because why? Because this one's not significant. So there are 4. Wow. Really? 4.
3.
And here?
3.
3, because that one's not significant. So there are 3 here.
I was going to ask about the decimal point on the number, second number.
Here?
What happens to that?
What do you mean what happens?
You just don't have.
I'm not getting rid of them. I'm
Okay.
just trying to decide how many significant figures I
I
have.
see.
I haven't gotten rid of the decimal. I'm just trying to decide how many significant. Because what is it telling me? That's the question. Why would I want to know this? This means when I look at this number right here at the top, it means that somebody made a measurement right here. When I look at this number, these are all measured. These were not measured, so they're not significant. When I look at this number, these were not measured. When I look at this, that wasn't measured. These were all measured. When I look at this number, they measured. They measured these 3 numbers, but they did not measure that one. That's what it's telling me. Okay? And anything that is measured is significant. You took your time to measure it. Shouldn't it be important? Sure. That's what it means to be a significant digit. Okay? This is the easy version. You can read all the rules in your book. I think they suck. Who likes following rules? She's too young. Following rules create social order, right? Good in some points. But you got to be willing to think outside the box sometimes too, right? And try to kind of bend those rules to think of how can I improve this a little bit. And that's why I think this is way better than having like 5 rules. It's got 2 rules. If it has a decimal, you start from the left, mark out zeros. If it doesn't have a decimal, you start from the right, mark out zeros. Everything else is significant. That's pretty easy, huh? You don't have to worry about where are the zeros, beginning, end, all that kind of crap, okay? And they have some examples. Like, here's their rules. Look, they only got 2 rules, but there's 4 parts here and 2 there, so they got 6 rules, really. And we're even. We're not talking about them. Now, when you have scientific notation, here's the key. All the digits in scientific notation are significant. 1.030 times 10 to the 5th. How many sig figs? 4. Everything in this coefficient is significant, so there are 4 here. Because it is incorrect to write 0.103 times 10 to the 5th. That's incorrect. Okay? Why? Because this coefficient's not between 1 and 10, is it? Okay? So we won't even talk about that. Not right. This has to be between 1 and 10. Okay? And all the digits in the coefficient are significant. So, identify the significant, non-significant zeros in each of the following and write each number in correct. I want you to work on these 3 problems, but I'm going to change the rules here. How many sig figs? And then write each one in scientific notation. Okay, so do all 3 of them real quick. Do it?
Like 8 kind of looks like 2 different numbers.
No, it's one number. It's 0.002650. Whatever program they're using puts a space in there and like that. Let's see what we got. How many sig figs in the first number?
4.
There's 4, right? Because we're going to mark out these first 3. So what we're left with is 4 digits. So they're all 4 significant. Now, I'm going to write 2.650. I have to put that last 0 there because it's significant, okay? It must be there. Times 10. I'm going to move the decimal 1, 2, 3 spots to -3. Okay? Meters. I should put a unit on there, shouldn't I? That's an M. All right, next one. How many sig figs here? 5, aren't there? Because they're all significant. I mark anything out. 4.3026 times 10. I'm going to move the decimal 1 place right here to the first grand. Okay? Because I move it to the left, it has to be positive, right? This number is bigger than 0, so the exponent here is positive. Okay? All right, what about the last one? How many sig figs in the last one? 4. There's no decimal. So we'll start over here, we'll mark those out, okay? So it becomes 1.044 times 10 to the 6 liters. Because we've had the imaginary decimal here. 1, 2, 3, 4, 5, 6. Okay?
So even though those zeros on the last one were not part of the significant figure, you still use them to figure out your scientific notation?
Yes. Yes. Because they're just holding that place right there, right? Because if I don't put them in there, then this would only be times 10 to the 3rd, and that's not the same as 1 million. That would be only, what, 10,000 instead of 1 million. right?
You would go all the way down to the 10th place, the ones place in between.
Where? With,
Well, you only go to the ones place, like when you're moving, deciding how many times to move it over.
yeah, because the coefficient has to be what? Between 1 and 10, right?
Okay.
Yep. The coefficient has to be between 1 and
Okay.
10. So you want one non-zero number left at the beginning.
Okay.